So you definitely want a calculator handy for this. So yesterday we hit all the vocabulary of stats, and then we hit norms CDF. So that was our big review yesterday. So the rest of stats is really about these confidence intervals. To make a confidence interval, you take your mean. So again, I'm just going to highlight here. And then you add and subtract 2 standard deviations. Okay? That 2 standard deviations is what percent of the data? 95. Good. So remember, it went 68, 95, 99. Represents 1, 2, and 3 standard deviations. Yeah, so you really wouldn't go out 4. 3 is as close as you're going to get. All right, here's the important part. Write your answer in parentheses with the lower one first. So it's going to go lower number, comma, upper number in parentheses. Usually you round to the nearest hundredth. Again, read carefully. If your value is within the confidence interval, it is usual. Okay? It is likely to happen, aka boring. If your value is outside the confidence interval, it is unusual. And that's where we say, wow, statistically significant. Okay, it's unlikely to happen. There's something forcing it to happen. It's very unlikely to happen. All right, let's look at example 1 here. A teacher gives a standardized test to his class. The mean score is 635. The standard deviation is 28. Okay, so how is this different from yesterday's? Notice they didn't say it's a normal distribution. They didn't throw that normal word in there for norm CDF. They didn't give me a min and they didn't give me a max. So I know it's not norm CDF. Using this data, create a 95% confidence interval. Okay, and then interpret this confidence interval in the context of the problem. So again, I'm going to find 2 times the standard deviation. That represents 95% of the data. So I'm going to say that's 2 times 28. 56. Beautiful. And then we take that number and we add it and subtract it to the mean. So it's the mean plus 56 and the mean minus 56. What was our mean? 635. So when you go to write that interval, it's parenthesis, lower bound, 579, comma, upper bound, 691. Okay, and this is our confidence interval. Okay, so it says interpret that data in the context of the problem. So again, this is a 95% confidence interval. So we can say 95% of the scores fall between 579 and 691. So anybody that's scored in there is likely to happen. It should happen. What is the margin of error? So again, the margin of error is specifically 2 times the standard deviation. So 56 is the margin of error. Number 2, a study at a local high school tried to determine the mean number of text messages that each student sent per day. The study surveyed a random sample of 111 students in the high school and found a mean of 199 messages sent per day and a standard deviation of 75 messages. So again, underline as you're reading. Jake is a student at the school and sends 300 texts one day. Using a 95% confidence interval, okay, so you have to write your confidence interval, is Jake's amount unusual? So take a minute. First, get your margin of error. That's your 2 times your standard deviation. So our margin of error should be 150 sounds great. So 150 texts, just so we're talking units of the problem. I want to get my upper and lower bound, so it's my mean plus my margin of error and my mean minus my margin of error. And then when we write that interval, it's parenthesis, lower, comma, upper. So I'm getting just 49 and 349 sound right? Okay. So now that I have the margin of error, I want to answer the question. And the question was, is Jake's amount unusual? So what is Jake's amount? 300. So let's make a nice statement. Jake's 300 texts is usual, since 300 falls within the confidence interval. You could also probably say the 95% confidence interval.
Do we have to spell out confidence?
You can abbreviate, that's totally fine. Okay, so sometimes you're just going to read the problem and get all your information. Sometimes they're going to give you a graph with it as well. So it says the CEO of a company claimed that 40% of his employees would like to participate in a community day. A simulation based on the claim was created. The chart shows the results of 100 surveys simulated 300 times. The CEO conducted a survey of a random sample of 100 employees, and 35 said that they wanted to participate. Based on the simulation and a 95% confidence interval, is this reasonable result? Okay, so the first thing I'm going to do is I see this, and I'm going to go get my margin of error, my confidence interval. So take a minute, get your margin of error and your confidence interval. How does my interval look? 0.3914 to 0.4094? Sound good to everyone? Margin of error, 2 times the standard deviation. Add and subtract that from the mean. Okay, so that's only half the problem. Now I got to actually answer the question. Based on the results of the simulation and your 95% confidence interval, is this a reasonable result? So what was the result that they're asking us to talk about? 35 out of 100. Okay, so you have to read and interpret the question. It says the CEO conducted a survey of a random sample of 100 employees, and 35 said they wanted to participate. So that is the result, 35 out of 100, which is 0.35. So what would I say about that result compared to my confidence interval? This is unusual. So we want to talk about the value now. So 0.35 is unusual. Don't say it, remember. It, we can't give you credit. Make sure you talk about the value. Since 0.35 falls outside the confidence interval. The other thing I would add in my sentence is 0.35 is statistically significant. Okay, it is unusual and statistically significant if it falls outside of the confidence interval. It is unlikely to happen. So in here, likely to happen. Anything outside, very unlikely to happen. All right, skip that page, jump to 45, difference of the means here. All right, so the last thing we talked about, obviously in stats, was difference of the means. So it says, given two sets of data, find the two means, and then find the difference between the two. Okay, and obviously differences subtract them. Sometimes they don't use the whole phrase difference of the means, and they just call it a diff score. Okay, that is difference of the means. All right, if that mean value, so here's the important part, if the mean value is less than 2.5%, or in the tail ends of the distribution, then you say, wow, there it is again. I love this phrase. Wow, that's statistically significant. If it falls in the 95%, we're saying boring, not statistically significant, and again, that's usual. Okay, it is likely to happen.
Is there a way to find out how many of the results with difference of the means happens? Sorry, this question is very hard to word. Without counting all of the boxes? To find out.
Oh, no, you usually count them. The way they ask it in this course, you usually count them.
So many.
I'm not arguing with that.
Count all that.
All right, so let's look at oh, it says given the same scenario. We better read this scenario here. 20 students were randomly split up into 2 equally sized groups. Each member of group 1 watched videos for homework, and each member of group 2 did traditional problem set. Both groups were given the same test at the end of the year, and the results are shown in the table. So group 1, what was that? This is the videos, and group 2 was tradition. Okay, they did the traditional homework. A simulation was conducted in which the subject scores were randomized into 2 groups 250 times. The results are shown in the graph. That's over here. Okay, so you're going to find the mean of the first group, find the mean of the second group, and notice the title of this graph is difference of the means. Okay, the title is a difference of the means. So I have to take these 2 means and subtract them. Okay, so if I subtract the means, we get 6.1. Now we have to go find where 6.1 is approximately on this graph. So it looks like this is 6. So 6.1 would be to the right, so probably anything over here. Okay, so the question is this 6.1 statistically significant? So that was what Dree was kind of saying. Do I have to sit here and count boxes? Well, you kind of do. So we've got 1, 2, 3, 4, 5, 6. If I double that's 12, 13, 14, 15, 16. Okay, and this simulation was run 250 times, so you're going to take 16 and divide it by the 250 times, and I think that's 0.064. Now that's just a decimal, and I want to compare it to 2.5%, so if I move that decimal over twice, that's 6.4%. So is that statistically significant? No. So again, this would be usual. This is likely to happen. Boring. It's not significant. To be significant, it has to happen less than 2.5% of the time. Okay, this is just likely to happen by ordinary chance. So it says, given the same scenario as above, Joelle found a mean difference between groups 1 and 2 to be a negative 7.6. So our difference value is negative 7.6. What inference can be made about the results? All right, so now we're looking for negative and 7.6 approximately. So here's negative 7.5. 7.6 is to the left, so I'm going left and on. That's approximately how many scores? Out of 250. You shouldn't have to count, it should tell you. Okay, it was the same scenario. So 4 divided by 250 is 0.016. So if I move that decimal now, that gets me 1.6%. So now I want to say, wow, 1.6% is statistically significant. Yeah. Oh, stick that on the charger and I'll give you mine in a second. 1.6 is statistically significant since 1.6 is less than 2.5%. Okay. So anything in those tail ends is statistically significant. Happens, it's unlikely to happen. There you go, go flip the page there. All right, you read this scenario. Looks like you have to find the means, the difference, etc. I'll give you a minute. So pretty similar to the previous question, nothing super exciting here. Did 233 sound right for the mean? And then was it 201.7? Okay, and again, because this is a difference table, I have to find the difference of the means. So 233 minus 201.7 turned out to be, I don't know my calculator. What is that? What is it? 31.3. Okay, so then I kind of approximate where 31.3 is going to fall. So obviously it's to the right of 30. So that's approximately how many values there? 6 out of a total of 250. And 6 divided by 250 is 0.024, which is 2.4%. And what am I comparing to again? 2.5. Therefore, this is, yes, 2.4% is statistically significant. I'm going to say this is unusual. Okay. And this is unusual. Outside that 95%. It's outside of our confidence interval. It's statistically significant. This is unusual. What else do I want to say? 2.4 is less than 2.5%. All right, one last one to tackle. If you got a little head start there, read the scenario to yourself. And then we have to talk about the inference that can be made after. All right, how does 91.8 and 91 sound? Everyone's good finding the mean? Difference value then is just 0.8 when I subtract. Now, hopefully your gut is saying, okay, so here's 0.8. That's to the right of the mean. So I need everybody over here. Does that look like less than 2.5% or 2.5%? Clearly no. Now, just for fun, I'm going to do it. I counted that there's 10 blocks between each of these, right? So I'm going to ballpark here. I've got 10, 20, 30, 40. That makes at least 50. That's close to, oops, I forgot this whole column. 10, 20, 30, 40, 50, 60, 70, 80, 90. There's at least 100 here, right? So I'm going to ballpark, even if I rounded and I said 100 out of 300? That's definitely 0.3. Even if I had to round to put a number down, I can clear, and again, it's literally smack in the middle. It is not less than 2.5%, but I could ballpark these numbers if I had to show the math here. So again, I'm going to say this is boring, likely to happen, what was I talking about? When inference can be made, but boring, likely to happen. 0.3 is not less than 2.5%. And again, it's super important that you're counting when you're close to the tail's end, because that's when it could be significant. But here, when it's close to the middle, it's obviously not going to be significant at all. All right, so you've got our total wrap-up on stats review. Grab the homework packet from yesterday. We were in the June 23 exam. Let's see. Excuse me. All right, turn to question 32. So that kind of goes in line with what we've just reviewed. Give yourself a minute for 32 or a minute or two. Read carefully, read the whole thing. Oh, So again, we've got this app design company believes that the proportion of high school students who have purchased apps on their smartphones in the last 3 months is 0.85. So they run a simulation and they find this data. Based on this simulation, let me slow down. Suppose a sample of 150 students from your high school shows that 88% of students purchase apps on their smartphone. Based on the simulation, would the results from your high school give the design company to believe their assumption was incorrect? So again, the first thing I should be finding is the what? Margin of error. So I've got my 2 times my standard deviation. What did I have for that? Just 0.058 sound right?
Yeah.
Okay, and again, the second I see this is what's leading me into I need a margin of error and a confidence interval every single time. Then my confidence interval, again, make sure it's in parentheses, min to max. I think I had 0.794 and 0.91. Sound right? Okay, so the question was, based on this simulation, would the results from your high school, what are the results from your high school that they're talking about? 88%, not this number up here. The results from your high school, right here that it said, your high school, matches up, word for word, your high school, your high school. So I'm looking at 88%. So all I'd have to do is convert these to a percent, right? So what percent are these? 79.4 and 91%. So what can I say about 88%? Okay. So would the results from our school give the design company reason to believe their assumption was incorrect? No. 88% falls within, I could say is usual. Boring falls within the 95% confidence interval that I've listed. So I feel like these types of questions are pretty obvious. They're going to give you that mean and standard deviation, and your mind should be going to a margin of error before I can answer any questions. Very different from those norm CDF questions. Okay. Let's see, I think we've completed almost everything else in the short answer. Okay, 31, the question before it. For all values of x, for which expression is defined, write the expression below in simplest form. When you look at this, where does your gut kind of lead you? That's what mine did first too, was long division, because I saw the fraction. But usually when it's long division, let's kind of make a note. When it's long division, they tell you to write your answer in q of x plus r of x over d of x form. So when I think long division, I'm usually looking for this quotient plus remainder form, and it doesn't say that at all. It literally just says to simplify this. What could I do to the top and bottom to simplify? I definitely have a GCF here. Yeah, I think that's just looking for you to factor. And I remember when we gave this exam that one year, this was probably one of the most missed questions because everyone tried to do long division because we've done so much long division. But I think it's just factoring. So what type of factoring do you have on top? What's that? Grouping. Excellent. So take your time, do your factoring, and then simplify. A quick grouping and a quick GCF. You might want to do the grouping off to the side. Just always do your grouping off to the side because there's so many steps. Merrick, what'd you pull out of the first two?
X squared.
And what's left?
2x plus 1.
2x plus 1. Okay, so if I group right, I should have a 2x plus 1 here. What do I want to pull out so that I'm left with 2x plus 1? Negative 9. Okay, so that was first GCF, second GCF. The third GCF is the binomial. So then I have the 2x plus 1 and the x squared minus 9. Can any of this get factored again? Yes. So I've got the 2x plus 1 and then the x plus 3 and x minus 3. So again, that's why I didn't write the fraction out right away. Grouping takes time. I need all of that. How about the denominator? What type of factoring did we have? Take out an x, good, a GCF, and you're left with 3 minus x. Now I'm ready to simplify. This grouping turned into this 2x plus 1, x plus 3, and x minus 3. And the bottom turned into x and 3 minus x. What can I then clean up? Yes, this 3 minus x and x minus 3, they're not the same, but their signs did switch, both signs, so they do divide out to a negative 1. Okay, so now when I write my answer, this negative 1 doesn't go to everybody, just leave it where it is. So negative 1, 2x plus 1, x plus 3, and then just over x. Just take your time as you're doing this question. So again, this was a little misleading. So just kind of remind yourself, if you don't see this quotient remainder, then it's usually not a long division. I mean, chances are it is long division on our exam, but this was the rare case where it was just a simplify versus a long division question. Let's see. Here's a quick one, 33. Patricia creates a cubic polynomial. So what should be going through your head when you hear cubic? 3 roots. Okay, so I'm thinking there's 3 roots. With the leading coefficient to be 1, so that's super important. So first of all, let's talk out a few things. If I have an x cubed, what does that tell me about the end behavior? Is it the same or different? Different. Excellent. So different end behavior. If the leading coefficient is 1, meaning it's positive, where does that tell me the graph ends? Up. Ends up. Okay, so those are, just by reading that sentence, those 2 things have to be going through my head. The zeros are 2, 3, and negative 6. So go ahead and, oh, it says write an equation. All right, so if the zeros are 2, 3, and negative 6, you should be able to write a quick equation called P of x. So start with P of x. If you know the zeros, you know the factors. Yeah, it doesn't say you have to clean it up at all. So I would just leave it as the factors. Are you hiding your work? I'm just here to help you. Merrick, if a 0 is 2, what is one of the factors? What? If the 0 is 2, what's the factor? You don't need to look across the room.
I don't know.
You've sat in this room this whole year and you don't know the factor?
I forgot that.
It's not. Oh,
X minus 2.
Merrick, if the 0 is 3, what's the factor?
X minus 3.
If the 0 is negative 6, what's the factor?
X plus 6.
Okay. So Dree said, do I have to clean that up? And nowhere in there does it say, like, standard form or anything goofy. I would just let it be. Is my leading coefficient 1? I could put a 1 there if that makes you feel better. But yes, it's 1, and there's your equation. Simple enough. All right, so now it says go ahead and graph that. So get your zeros plotted. I don't know if I should laugh or cry. Got my 2, 3, and negative 6. And again, we said the leading, it's odd, so they have to end opposite. So it's going to, these directions or these directions. And the leading coefficient is positive, so it's going to end up, which means it's got to start down. And all you're doing is connecting what it could. Now, could you even graph it once you've written the equation to see that it matches up? Okay, so take your time. We want to make sure. And I might do it just to be a little more exact on my zeros. So I have x minus 2, x minus 3, and x plus 6. And a quick zoom 6, so I know exactly what it's looking like. I can see, oops, it didn't like something in there. I got junk typed in there. Let's see, when x is 0, it hits at 36. So I'm going to plot that point as well, and I'm going to label that 36. Okay, so I have my y-intercept and my x-intercept. Obviously, it looks a little smoother than that, but we've got the idea. All right. Turn to the beginning here. Let's tackle 1 through 13. 1 through 13. So whatever we don't finish in the next 4 or 5 minutes is homework. 1 through 13. Use your calculator as much as you can. If you're committing to an answer, make sure you've checked on the calculator.